Good evening, ladies and gentlemen, and welcome to the second of the 5 Atheneum Geschke lectures of 2017. Our speaker tonight, Professor Robert Traver, has been a professor for 20 years in the Department of Civil and Environmental Engineering at Villanova University. Dr. Traver has a BS in Civil Engineering from VMI, a Master's from Villanova, and a PhD from Penn State. He is a widely published, nationally and internationally recognized expert in stormwater management. He is actually actively involved in water-related panels, including a panel charged with the investigation and reporting on the failure of the New Orleans levee system during Hurricane Katrina. He is the founding director of the Villanova Urban Stormwater Partnership, and his current research is focused on the advancement of green water storm infrastructure. Dr. Traver initiated a stormwater research park that has transformed the Villanova campus into a living laboratory with on-site experimental projects such as green roof, rain garden, stormwater wetland, and pervious concrete and asphalt. He's going to explain all that to us tonight. We will learn tonight about the real-world application of these concepts in the world. I now introduce Rob Traver.
Thank you. I don't think I'm supposed to use that one. So,
Okay.
If we hear feedback, we'll know why. Only 20 years. You're being very generous. I appreciate that. Thank you very much for inviting us here today and holding this. It's always interesting to go to different areas of the country because the water issues are different everywhere you go. So I've done a little homework here, so hopefully I can stand up, and from the conversations at dinner, I'm sure I will be corrected if I don't get it all right. But anyway, what is sustainable green stormwater and why is this important to us? So I started taking a look at, thank you for sending us some material ahead of time, and been looking at your site page for your municipality. And like many areas of the country, you have something called a TMDL, the total maximum daily load, and you're specifically focused on nitrogen. And what that means is that is a requirement we have in the Clean Water Act to looking at our waters and get them to fishable, swimmable status. And in this case, your area is limited by nitrogen. And it's very common, and this is all over the country, but each one is a little different. But yours is nitrogen, and it's basically related to scallops. From what I understand, your scallop industry is is not as productive as it was, and it's off a little bit every year. I found this last night, so I had to come in early enough to do so little investigation of the beaches. And scallops, obviously, that represents an industry, right? It represents a way of life, and something Nantucket is very famous for. And it's a very tasty morsel, and just like Chesapeake Bay, they've been highlighting their crabs. You're very similar, but now you're talking about scallops. And they are limited by nitrogen. And this is, again, from your website, from your local town, from a presentation, I believe, involving some of your septic tank systems not very long ago, but it shows that when you take a look, especially at your bays, you have pollution coming off the different watersheds coming in, and it does affect, I believe it's the eelgrass and the production of the scallops in the environment. So as an engineer, our job is to try to figure out what to do about it and bring it to the citizens to see if they want to follow through with that. So from this report back in, I think it was 2009, they took a look at where is all the nitrogen coming from. Some is coming from atmospheric deposition to the surface. You're not going to be able to do anything except maybe vote 4 or 5 times, because that is obviously a national issue about air pollution and coming out of the atmosphere. Fertilizer is part, septic is part, sediments. Sediments might have been there for a long time and they have a certain amount of nutrients or nitrogen in them, but if you cut the source of nitrogen coming in, they'll eventually start decreasing. And then you have the atmospheric deposition to the land surfaces. Now, I would have put that with runoff, and the fertilizer with runoff, and some sediments with runoff. So runoff, it really isn't 5% of the problem, it's really actually a lot higher. And if I take the same report, estimated at what can be controlled by human activity by the citizens of Nantucket, and that would be, these are the three that they came up with, and these are the targets. And I'm not going to pretend, I was reading some articles for and against septic systems and replacements. I'm not going to get into that tonight because I really don't know all the background. But runoff is something that is being targeted, and the fertilizer as well, which I would kind of lump the two of them together. Because where does the fertilizer go? It usually goes by the runoff to the streets and into the systems. And this is not just a Nantucket problem, this is a United States problem. All over the country, when we taking a look at the natural environment, most of the water infiltrates into the ground or evapotranspirates into the sky. The great proportion. Very little of it actually gets in the flooding in the rivers. That's a very small part of my yearly water cycle. And of course, that changes completely in the urban environment. You have a lot less evaporation, a lot more runoff, and very little infiltration back into the soil. So this is a problem in many areas. And it's kind of interesting. When we first started looking at this, we just looked at the big storms. You know, the Sandys, the Floyds, Katrinas. But then we started realizing from a water and environmental issue, it's every little storm. So if I take a look, this is from a gauge in Maryland. On the one on the left shows the effect on the rivers from the runoff from a green area. And the one on the right is from downtown Baltimore. And you can see the amplitude from the same rainfall, how much more of a problem it is every little rain is amplified and accelerated into the system. And the results all over the place, and these are some old slides, but there's some flooding in Pennsylvania. Obviously, you have floods, sediments, polluted waters, property loss. The rivers move through the accelerated water that will take property and give property to other people, I guess, as the rivers move. And I know not even somebody, who's the rival of Nantucket? Is there a rival? Martha's Vineyard doesn't even put sanitary sewer manholes in the middle of a stream system. That's evidence where that river has been moving. These are all issues. They're economic issues because we have to pay to fix them. All the pipes are too small. It's a big problem across the whole country. And when we take a look at the biological response, it's kind of, when you start taking a look at all the stressors, whether it's flooding, habitat loss, the chemicals, the pollutants, heat, runoff of asphalt can be very hot and can change the heat of a lot of the stream systems. All together as a package, it's not very good on the biological activity in the rivers. So, a couple of years back, people decided we're no longer going to look at just the big storms, about 15 years ago. We better start taking a look at the smaller storms, what they call the non-point source pollution, which is what we're talking about in Nantucket as well. Some of the bigger cities, like Boston and Philadelphia, all over the place, also had a problem. This is a lithograph from, I'm a big history nut, so I apologize if I had to throw some old pictures in here. But here's Philadelphia in the, I believe it's right after the Civil War, because we got steamships and we got sailing ships. You take a look at this massive city, and just think of this city, and think of having an outhouse behind every one of those homes. Obviously a public health issue, and a very large public health issue. Now, why somebody in 1902 would take pictures of outhouses, I have no idea. But I appreciate it, because it kind of shows some of the public health issues. And so Philadelphia and many cities in the United States started building what they called combined sewers. So they bricked over the rivers, they basically flattened the areas and built houses on top of them. And that became the way of getting rid of both the sanitary sewer and the runoff. Philadelphia, for an example, this is a picture. You can see the natural streams, and you can see this picture. They're all gone, and they all became combined sewers. And it wasn't until, at least in Philadelphia, the 1940s, that they directed these to a sanitary sewer plant. Well, the problem with this, in many cities across the nation, is there's not enough capacity during storms. So if you get a half inch of rain or a quarter inch, 4/10 of inches of rain in many parts of Philadelphia, we have raw sewage going to the Delaware and the Schuylkill River. And there's probably about Minneapolis, Baltimore. Boston used to, but they built big tanks underneath. So this is a major problem in many, many U.S. cities. So, finally get to and solve all these problems, a new field was invented probably about 10 years ago, 15 years ago. It's now called green infrastructure. In China, they called it Sponge City. In Britain, they call it SUDS. I kind of like that better. Sustainable Urban Drainage System. I tried SUDS with my fish and chips yesterday. But anyway, but really, it's a new way of looking at stormwater management. What we're going to try to do in stormwater management is use that infiltration and evapotranspiration and the natural processes to include the soils that are very good at breaking down some of the pollutants or capturing them instead. And so it's been a new way of thinking. So the idea is, on the left, you can see here's the natural system. A lot of precipitation, a lot of evapotranspiration, very little runoff. If we just pave, we get large volumes of runoff. But what we're going to try to do is bring that back to the urban water balance and bring some of the green back in. Philadelphia, for an example, decided instead of building gigantic tanks underground like Boston has, that doing that, after you build the tanks, they're really not helping you. They're stopping the sanitary sewage, but they're not adding jobs, and they're not adding to the life of the city. Philadelphia's decided to green the city instead. 40-year plan. It's not a fast plan, because they thought they're going to add jobs, it's going to improve air quality. So it's a kind of a revolution in the way and a lot of cities are looking at Philadelphia and following this same approach. So it's still fairly new. But Villanova, we're very lucky. We got in the forefront, and we started building sites about 15 years ago and have been testing them as a research site. So we've been able to turn the campus into kind of a research platform. So for an example, here's my favorite green roof on our SEER building. My dean's over here, I have to say that, but it is. And basically, here is a porous pavers. There's little slots between all the porous pavers where water goes down into a rock bed underneath this area. These are a demonstration project. This was porous asphalt. This is porous concrete, where water goes right through those surfaces into the ground. This is an infiltration trench off a parking garage. We'll talk about some of these in a little more detail. We have an acre stormwater wetland on campus that we've been studying for quite a few years as well. It used to be a mowed detention pond for flooding, and we rebuilt the site. Treatment trains, my favorite rain garden, and this is my newest picture. I added it in. You know, when you think about water usage, Villanova took a parking lot that had no controls and is building a whole set of dorms and other facilities across the street in this park where this parking lot was. The parking lot is now turned into parking garages, so they're not adding impervious surface, but they're using water from the runoff being captured at the roof to run the heating and air conditioning system, which uses a lot of water. So again, that takes water out that used to evapotranspirate into this air, and for the past 30 or 40 years have been eroding rivers downstream and taking it out of that system. So lots of innovative ways of taking a look at these particular practices. So, and I remembered I mentioned small volumes. Philadelphia has settled on 1.5 inches. But basically, when we start taking a look at the flooding, we used to design in my area for 8 inches or 7 inches of rain. Problem with that is we just kind of ignored the smaller rains. But now we're finding if I take a look at 1 inch of rain and capture all the water in the first inch of rain, I have 80% of Philadelphia's water cycle. So that's a lot of water. So these small rains can be very impactful and are really the focus when you're looking at things like nitrogen in your bays. They also help for the flooding. After working on Katrina, believe me, I know the effects of flooding. So I'm not downplaying that need. But there are like 2 different systems that you take a look at. By the way, I don't have very many graphs. I figured that this would not be a good audience for graphs. So I'm trying to spare you, but I have to show 1 or 2. I am an engineer, after all. Anyway, so I want to show you one of my favorite projects because it's so simple and it's older. And this is our rain garden we built about 15 years ago, 16 years ago now. And basically what we did was, this was just a traffic island. And we dug it down and put soil in there and put curb cuts to get the water in. You can take a picture. I think they're going to have my presentation. and I'll be glad to send you one if you want one as well. I'd have to comb my hair if you're going to take a picture. But you know, very simple. What you're looking at here is inlets comes into the rain garden. It's designed for an inch of rain. So half the inch is within the soil, which is a sandy soil, and half the inch is above it. And then a day or two later, dries off. And this was built back in 2001. And it's planted with not wetland vegetation, because most of the time it's dry, but we picked South Jersey beach plants because we figured they're used to the salts and used to this type of environment, sandy soil and wet and dry. And it's still there today. In designing it, you take a look at it. For an example here, what we're showing is we take about 10 times the surface area of impervious surface coming in. That's kind of a rule. Some places say less, some places say more. And when the water comes in, and by the way, all my metrics are in violation of the local Pennsylvania DEP regulations on building these, but they paid for it, and I built it before they wrote the regulations. So, but basically, we found that this site works incredibly well, and we simply dug it out, made sure not to compact the surface, put a sandy soil back in, and planted it. Oh, I'm 16 years old, a little older than I thought. And basically, then we instrumented the heck out of it. As I said, we could have done a lot of business with you. Sorry about that. We have water samplers for water quality, all sorts of sensors for measuring the flows. So this is a very heavily instrumented site. And then from that, we've started learning how it works, because we kind of built it, engineers, only soils I had was we compacted the heck out of it to make it nice and hard. We didn't have, my experience in gardening is my vegetation experience. So we started working with other groups on this, and we found that the different parts work differently. So here's my bowl and my surface storage, and we also have a media. And what we're finding in the media is the roots of the plants are very effective at removing the water out of that media. When we first started building them, people thought they're going to be water all the time, but they're not. They're mostly dry. So we found that this void space in the media is usable, and then this starts coming to be a very complex engineering process, because I got water, I got geotechnical aspects, I have to deal with the water chemistry, you start dealing with the plants. It gets to be a very complex engineering problem. And by just simply taking a look and measuring every storm, I'm sorry, I'm not sure what's going on here, but we find just looking over 15 years, the infiltration rate is slowly starting to increase on this site. And we think a lot of that is just frankly the roots of the plants are drilling more holes through the soil as it starts moving through. Since we talked about nitrogen, I had to throw a nitrogen slide. I'm sorry this is so busy. And we changed our nitrogen test a little bit, but we're removing about 90% of the nitrogen from the water coming into this particular system. Now, a little bit of a teaser here. We're removing about 90% of the water going through the system. So, I mean, basically, you don't have to do a lot of math. If I get rid of 90% of the water, I'm probably getting 90% of the water, of the nitrogen coming through as well. But we've also been looking underneath this water, underneath the soil, and looking at the water as it moves through the soil, and look at the chemical properties of the soil. And the short answer, I threw this in just for you two. The short answer here is at the surface, down to 4 to 8 feet down, which is probably more than you can get, we're getting pretty good removals. This is a probability curve, just looking at it. So at about, you have a 50% of the storms are dropping it down well below, I believe, your TMDL requirements. And the funny thing is, after 4 feet, it doesn't make any difference. It may not make any difference after 2 feet, but I don't have any sensors at that particular point. So we're learning that these sites work very well for water quality, water quantity, and better than we ever thought. And again, now we're starting to get into computer modeling and simulation, and we still have a long way to go within the profession. But what we're really finding is most of the sites we build are doing better than what we thought they would, which is a good problem. It doesn't happen often in engineering. And it's also a very useful place to put snow. It's amazing how high our facilities department can throw the snow in there. So now we're starting to look at the snow impacts. And the biggest impact of the snow in Philadelphia is salts. You're right. Nothing removes the salts, they go right through. But of course, if you put this on the grass, the same thing would happen. So this does not help chlorides. We have some other projects in Villanova. I'll talk about a couple of them. For our green roof, this was actually a retrofit. It wasn't designed as a green roof. And we worked with the facilities department in putting this in. And we've been testing it for a while. And we learned some very important things. One, it's very effective again. Now, this is just evapotranspiration. So we're looking on a yearly basis and not including the winter for the studies. We're just getting to those. But we're looking at between 70 to 80% of the natural cycle. We're able to remove all the water from the green roof. You know what our biggest problem has been? Professor, I'm trained to wait till somebody answers. But it won't do that to you. It doesn't rain all the time. So when there's no water, guess what? We have no evapotranspiration. It's just kind of sitting there. Sedum plants just kind of shrivel up and wait for the next rainfall event. So we started thinking about that this site could get rid of a lot more water if we could get it to it. So we take a look at our engineering building and our gray roof. We have a lot of water coming off a gray roof that it does not have a green roof. And so what we did was we piped it down into a tank. That tank now goes, and when the green roof is dry, which we use sensors, soil moisture sensors to determine if the green roof is dry, to water it so we can get 2 or 3 times the performance out of the same, which is going to be a heck of a cost savings. And this is the firm we're working with is from the Boston, Massachusetts area, and they're getting very popular for this. They even have it set up where they watch the weather forecast, and if there's a certain probability of rainstorm higher than what we have available in the tank, they actually empty the tank before the rain comes so they can get more of the storm flooding issues. The other thing we've learned, again, from this is how powerful the evapotranspiration force is. It's much more powerful than we thought in emptying the water after a storm from all our rain gardens, which is very good news. So doing the projects in tandem has also helped us as well. We also, I don't usually throw this in, but we also have a constructed stormwater wetland that we're working with. I've ran into a few on the island during my hikes out to, what was that beach? Jetty's Beach? Yeah, I saw a few out there in the conservation areas you had out there. And we turned an old detention pond into a stormwater wetlands. And actually, I should say, whenever I said we have a whole bunch of grad students and a whole bunch of professors. So it's not just me by any stretch of the imagination. But Bridget Wadzik has taken on this project, has been working on it for, I guess, 10 years now. And we have about 45 acres coming into a surface area wetland, less than an acre. And basically, pretty much, we find we get rid of about 20% of the nitrogen during storm events. And the big hit, we get rid of about 50% during the base flow, the low flows, which is probably the most important part of it. Still lots to be learned on these processes. We've built our wetlands so the water has to zigzag and take a long time to go through. And it's been a very interesting study and very, very pretty area. Talk about if you're a birder and you want to go down there, it's great. The only problem we had is we had one part of our university wanted to put bluebird houses, and I know the hawks love this site. For some reason, I didn't think they might not be happy with that outcome. But it's a beautiful area, as they say. We also had kind of an interesting one. How bad was Sandy here?
It's mostly south, right?
Mostly south. It really didn't hit you here? Flooding. Well, what's that? Okay. Yeah, we had, well, let's just talk about this site. We built this site as a long distributed site. And the reason we built it as a long distributed site was trying to mimic areas where you don't have a lot of land, but you might have a linear feature. And they call it kind of a treatment train approach, where actually we have a few little rain gardens and a swale in between the two. At the very end, it went into a rock bed. And here's another picture, just schematically, coming off a parking deck. And the nice thing about parking decks, they're high and you have water can be pushed down. It makes it a little easier for transport. But we built this whole thing trying to get rid of an inch of rain. And then we had Superstorm Sandy. It's very interesting when you're watching the news and you see the track of the hurricane is over your house. We mostly had wind damage. But at Villanova, we had about 11 centimeters, or was that close to 4 inches of rain? Almost no water escaped this site. And the site was designed for 1 inch. And the reason why we think it was doing that is we don't pay much attention to the processes of infiltration during a storm event. But Sandy to us was a couple-day storm. It wasn't a very hard, it was a heavy rain for several days, not a super intense rain for a short period of time. So from this, we're starting to try to look at these a whole different way about how we can bring them in for flooding as well and use some of these capabilities, or make them smaller so you don't have to spend as much money building them. Philadelphia, as I said, they're trying to green the whole city. They're looking at a 40-year plan of thousands and thousands of sites. And here's one site. This is a pretty one. It's at the Philadelphia Zoo. It's the Giraffe rain garden, Giraffe lot, I should say. So my grad students forced me to make sure that our instrument pole looked like a giraffe here. But we are looking at radiation and rainfall and wind speed and all sorts of pressure to really instrument the site very heavily. And this site was again designed for about 1.6 inches. And this is for you, all the sensors on the sites. I don't believe how much money you can spend on sensors. We even had to invent some flow meter devices because they were not available on the markets. Basically, we've been working on this for a couple of years for the EPA. And we found out Philadelphia Water Department, it's nice being a water department. When they want to test a site, they turn on the hydrants. And I thought, that's a great idea. So we're turning on the water to fill up the sites for testing it. And we really wanted to stress it. Here's the second and the last graph that I have. And what we found was we put in 2 inches of rain and barely reached the highest levels of the site. So that's more than it was designed. Then somehow, I got a new clicker here. Sorry, I'm not used to it. Somehow, overnight, we had an unexpected 1-inch rainfall. And then the next day, we put another 2 inches down. So we put in like 5.5 inches of rain into a site designed for 1.5 inches. And now we're trying to figure out why it's working so well, because it violates all theory. And frankly, I think the clue was we see hundreds of earthworms swimming during the tests. And earthworms, they put holes through the soil along with the roots, and all the engineering equations do not assume that they're there. Now, how we build that into a computer model, I have no idea yet, but that's why we keep on doing research, as we say. So it makes it kind of fun. We're thinking about trying to figure out a smoke bomb underneath of it to see if we can see the smoke coming up and see if we can count the holes. And the other issues we're working with Philadelphia Water Department is on maintenance. This is an entrance to the site. They added a little asphalt patch to force the water to go in. They didn't make it big enough, didn't have enough slope, and now they have to keep on going out and cleaning it out. If you have thousands of these, you can't do that. So we actually are working with them as a research agency on some of these, trying to apply some hydraulics to come up with better designs. And we also get involved a lot of the community. I'm not supposed to do this on an engineering research talk, but we love working with STEM, with some of the kids. I wanted to adopt this kid. He's building a wind speed device using Dixie cups. I don't know why we spend thousands of dollars buying these things. And working with the water department, we do a lot of public education. And so this has been a very rewarding part of our job, and our students get a lot out of it as well. So let's bring it back to Nantucket. You need to reduce some of your stormwater impacts, right? I see a lot of you are doing a really good job. This is a lovely home, and if anybody owns these homes or I say anything bad about them, I'm sorry. I have no idea. These were from yesterday, walking around, and this morning. All the downspouts of this house are going into those gardens. I saw a lot of homes had that. Some were not doing that. But I took an aerial photograph of Nantucket and measured all the rooftops, that's a lot of impervious surface. And this would be, and also, I also saw some firms that were going out and watering a lot of the gardens as well. So, I mean, cisterns, capture, reuse of these would be a way of reducing some of the water coming into your systems. This one was, they had a fairly new home, it looked like, and they had a very large island. Now, I don't know whether the rooftop runoff and these areas here bring the water into that garden, but that would be a great idea. So things like that, very simple things can be done. Conservation areas are great. I saw the biggest rabbit I've ever seen in my life. He was very well fed coming out of those. I know that's not something you like, but some of those are wetland areas. I'm sure they could probably use a little more water. You would have to get some environmental person who knows more about the water quality aspects of it, but that's always a way to make a use of some of the natural landscape. Here's another one I saw I thought was interesting. And no, what is it, South Beach Drive? Going the jetties. You can see right off the bat that all this area was sloped to go into here. This whole area was mowed. This little area here, the water was still sitting there from last night. And it probably shouldn't have been. So maybe that was an area the groundwater is a little higher. Maybe, I suspect, since it was compacted during construction. But some nice wetland plants are starting to emerge here. If you probably just didn't mow that, it would probably be a pretty nice little area, or uncompacted. And of course, what I would do is have the street come in. There's a berm that's preventing the water from going into the street. You have a lot of places that looks like this. The problem with this is a mound. If that elevation was lowered, that could make a very good environmental stormwater control measure for getting rid of some of the water flows. This doesn't help you a bit. That is, water is heated, moving sediments, and in front of my house looks like this too, so I hope I'm not insulting anybody, but these are the type of the practices we should try to move away from. I know it's tough. You have a lot of narrow streets, so does Philadelphia. Every area has to have its own solutions. So, and some images of the future green Philadelphia, and I try not to take the 3 hours I was told that I would be allocated, like I do my graduate courses, but I would be glad to have a discussion or conversation. Yes, sir.
I went to grad school in Philadelphia. How did they manage to pull together a 40-year plan?
Well, first they were told they had to. EPA. Basically, it's against the Clean Water Act for cities to dump sewage into the Delaware and Schuylkill. And so they did about a 10-year process of studying. Where'd you go to school?
Law school.
Okay, that's okay. I've lectured there. As long as you're not Penn Engineering, that's okay. But basically, they spent about 10 years studying the issue. And they looked at the economic cost and benefits. And they figured out if you built enough tunnels to store this water, it would be about the same cost as greening the city. And the greening the city, they're looking at the benefits of jobs, better air quality, more livable city, temperature changes, There's even studies that show when they...
Nothing of the downriver benefit.
Oh, not even bringing that into it. So they are increasing some of the sewage treatment plants as well. So it's not all green, but they did a combination of green and gray. And, like now in Philadelphia, your water bill is based upon your water usage and your paved areas. And because it's an expense, they have to treat the water coming off those paved areas. So that's a big change. So if you were a car dealer, you might have paid a couple hundred a month, and now you might be paying a couple thousand a month. But if you reduce the impact, it reduces the water bill. They actually have found it's a lot cheaper for them to build on private property than public property, so they're doing a lot of public-private partnerships and actually paying you to build it and reduce your water bill, because it's cheaper for them to do it with you, but you have to agree to maintain it. So, yes, sir.
What's the projected 40-year cost?
Oh, a lot. I am an engineer. I have to get it back. It was millions.
Millions?
Oh, what's that?
Millions or billions?
I will get back to you and let you know that. It's on their website. I mean, it was actually a little cheaper than building the underground tunnels because of the size they would have to be. And you saw all those rivers. It's interesting, in the 40s when they're building ships for World War II, the water coming in, before they had the sewage treatment plants, the water in the river was so bad it was peeling the paint off the ships they were building and making all the workers sick, which is why they built the first sewage treatment plants there. Yes, sir.
Your experience with pervious pavement, pros, cons, maintenance issues?
Yeah.
We've had a couple of projects on island, but they haven't really gotten any traction. I'm just wondering.
The green, I think, is more resilient. I mean, but you can't always do that. We have built porous asphalt and porous concrete. Porous pavers, I'm a little suspicious of all those little slots, how you maintain that. I'll let you know in a couple years because we haven't studied that. What happens on the porous pavements is the surface captures the sediments, and that's where all the pollutants are. So when you vacuum it, you remove those pollutants. If you don't vacuum it, they'll clog. There's a study in Sweden. Porous pavement's been around since the 70s. It is not new. There's been enough studies that show if you maintain it regularly, it's going to work. If you don't maintain it, it's going to fail. It's like an engineered system. So I don't like when people want to put it through a park. We have all the green stuff on either side. Philadelphia has some porous alleys. Advantages of it is you never have black ice because it melts and goes right through. Disadvantages, it will clog if you don't maintain it. And when you're building a parking area, if you can't get a vacuum street sweeper in it, that area will clog. But that's not that. And now they're making vacuum street sweepers that are designed for porous pavement. So they're a lot better than they were. I'm not going to build any more at Villanova until we get a better vacuum street sweeper. Yeah. Ours was a rebuilt one, which was fine for the purpose, but you really need a good vacuum street sweeper. I want to do people's driveways unless you have a system for also vacuuming those driveways. Concrete lasts a little longer than asphalt. The problem of concrete is any concrete, you can't put any chlorides on it for 12 months. And that's hard to do in the winter. The price depends on the price of oil, which one is more expensive. But porous asphalt probably doesn't last quite as long, but it's a lot easier to put down. Yes, sir.
You talked about the nitrogen load on the rain gardens, in particular at Villanova, and the removal. And you mentioned it in terms of total nitrogen. I would like to know if you have a breakdown of what forms that loading nitrogen is. Is it, what is the NO2 value, for example?
NO2 and NO3, we also, I don't have that slide put in, we're also looking at those. What we found is kind of interesting. The NO2, NO3 underneath the rain garden is lower than it is underneath the grass next to it. We see a drop as it goes through, and then it kind of stays steady. So after the first foot or two, there's no change. Now, other people have had different results. Our rain garden is very slow infiltration rates, and that's why I think we're getting removals and changes. A lot of people build on pure sand, they don't see much change in the NO2/3. It just goes right through. Some people are building them with denitrification chambers. They're lining them, and so there's always some water in them because the way you get rid of nitrogen, obviously, except if it's binding to the soil, is through nitrogen gas. So there are some people that are basically lining the bottom, so you always have like 6 inches of water at the bottom and start that denitrification.
Have you had any experience with wood chips to bind with the NO2?
The problem with that is Seattle did that, and then they reported exporting nitrogen. Because the wood chips work very well, but you need to replace them periodically. And so in Seattle, they were doing a lot, and there's a lot of manufacturers who make I guess it's a tank you put in, and then you have to replace it every once in a while. Seattle put them in, and then left them in place, and then all the wood chip starts breaking down, and now they're exporting nitrogen. So be careful what you wish for. Yeah, so basically now I must admit, I am a water resource person. I know enough of, on the environmental aspects to be a little dangerous, but I know some people who are very smart in dealing with that. So that's where a lot of that information is coming from. I did some work with people at the University of Maryland and NC State, and some at Villanova working on it. But we're finding our site, and everybody else is telling me they think our site is reducing it because it's so slow going through. Now then the other question comes in, there's a lot more water going through our site. So even though the milligrams per liter is low, we have a lot more water going through. So then you have to do the mass balance, which is why we're really trying to understand the evapotranspiration more. And we just finished a thesis, and I think until we get about a half inch of rain, all the water is evapotranspirating and almost nothing is infiltrating into the ground, which to me is really good news. Because a lot of people are all concerned about how much water is going through these systems into the groundwater systems as well. So we have a lot to learn still. Yes?
Have you had any of the water gardens fail in terms of filtration or?
Yes, I have one. We have about 18 at Villanova. We had stimulus spending a bunch of years back, and I thought, being a good citizen, we built about 8 rain gardens around the campus, not really for research, just for, trying to beautify the campus. And the way we did it was we scraped out about a foot of soil, mixed some better soil with it, built a little berm, cut the downspout, and that was it. One of those is a beautiful wetlands. Nobody else knows that it's a failure except me, because it looks great. I mean, the cardinal flowers, and that was probably because it was compacted during construction. Then underneath and basically, if we had probably dug down 3 feet and done it, it would have been fine. I have one other one. We're looking at some at PennDOT that have failed. I shouldn't say we're working in 95 in Philadelphia. We got 6 more rain gardens we're studying there, working with Temple University as well. And a couple of those have failed. And what I usually find in the fails is it either was not built right or it never should have been built there. But if they start off and they're built correctly and they're working, they should work for I should not expect a problem. All the failure mechanisms are at the surface, so except for construction. We have one at Villanova that was compacted during construction. It wasn't one of our research ones. It's behind our basketball pavilion. And even that works. It just works very differently. They compacted during construction, and it's very, very slow in infiltration, but it's still effective. But usually, I love it when I have an engineer, these things don't work. It doesn't work. I said, well, what's the problem? Well, we didn't build it right. We used the wrong soil that compacted it, but I don't understand why it's not working. So but luckily, the profession is getting used to building them now. At the very beginning, we had a lot of problems, but now people are using it. In Maryland, there was a study where they had a lot of sites that failed. If you go back and look at the report, they built a rain garden, they put grass seed and all the soil around it. So while the grass was starting to grow, all the sediment came in and clogged the system. And they said they were very worried that only 50% of them were still working. I thought it was a miracle that 50% of them were working, just because of the poor construction practices. You have to build them right. So I looked at these as an engineering structure. We should have an expected performance, but it has to be built correctly. And that's a learning curve, especially when nobody's built them in an area. You have to really work with the contractors and educate them. That's your job, right? Yeah. Yes, sir.
I was struck by your slides, that historic slide that had all those streams in Philadelphia.
Yeah.
Kind of got paved over, and it reminded me in Los Angeles, I think they're trying to reverse the paving over of the LA River. Is that possible broadly, or is that?
It depends where you are and the volumes of the water going through. Philadelphia, they're doing some of it. They're trying to re-daylight some of the areas. But some of these, you can drive 2 tractor trailers next to each other. They're so big. They're very large. In Philadelphia, they're not doing a lot of that. They are doing some areas, especially like the headwater areas, but it's not easy because all the homes have been built over top of them. So they're trying to stop the water from getting there in the first place. So they're redeveloping some old row homes in Philadelphia. They usually put a little green roof on the top. There's a nice little outdoor seating area. They're building a lot of infiltration pits. They actually have a program out. If you see a site where you think they would build a good rain garden, they'll come and look at it and try to build one there. Say, if you look at the Philadelphia Water Department, they have a link to a map about all the sites built. There's got to be well over 2,000 by now. And they're still only in the first 5 years of a 40-year project. Biggest problem is space. And walking down some of your streets, you have the same problem. There's not a lot of space in some of these areas. Yes, ma'am.
Do you have any advice for a town that has many, many cobblestone streets? Have you worked with cobblestones? Is there anything special that we could be thinking
Well,
about?
they're rough driving over. I would say I would first start at areas where you have a little land, a little space. Philadelphia has built a lot of tree trenches, they call them. So take a section of sidewalk and build a filter area to capture the water off the street and then go down through that section of sidewalk. So it's like, and then you plant a bunch of trees in there. So it'd be a media filter, and then you would, actually, think of it. I don't know why I always point this at the stream. Oop. My wife. Vacation photos, sorry about that. Hawaii. Wearing the wrong shirt. She went to Penn State. But it's, they basically will take like a 100-foot section of the roadway, pull off the sidewalk, put in a sandy soil line with a geotextile fabric, plant trees, and then have a filter for where the water comes in. And so they either put a sandy soil or a rock bed. I want them to put a sandy soil. Most of theirs are rock beds. And basically, so the water would come off the street into them. So I don't think I'd mess with the cobblestones. I think I'd take the water where it comes off the cobblestone, and if you have an inlet, do something like that. But they also have a maintenance program. They go through, I think, twice a year and have a vacuum truck that sucks out the pipes that go through that system. Yes?
The parking lot that you showed us earlier with the retention area in it that you engineered at Villanova, you showed later on in the winter that it was a good place for dumping stuff.
Oh, that was, yeah, the rain garden.
Okay, and you asked us the biggest problem with snow, and the answer was salt.
Right.
Are you monitoring the effects of salt and ice melts? And of course, a lot of these salts today are coated with calcium chloride,
Right.
so they stick to the road better. And of course, when we drive down the highway, we see signs that may say low or no salt use because
Yep.
it's a reservoir area, and really our entire island here is a reservoir area.
Yep.
Having a sole source aquifer. So do you have any opinions or wisdom to share with us on introducing more use of salt and ice melts, which is happening here as the years progress?
Well, you're getting out of my research area. I still remember driving on snow-covered streets, so apparently we can't do that anymore. The salt is an issue. I know that basically if the salt, we've tested and we can show salt where the snow is just showed up in the grass and that we see high salts underneath. And we see high salts in the groundwater. The water column moving underneath the rain garden. We do not see, as of yet, any change in the groundwater chlorides. However, places like Sweden and Canada have shown that there's a change in the salinity of the groundwater. Of course, they obviously are a lot colder climates than we are. I know PennDOT is working on a lot of different areas. They're trying to put a thin coat down before the storm to reduce usages. But if you solve that problem, we'll be able to buy a new sloop and go out sailing for the rest of our lives. It's a big problem. And it's just not green infrastructure, it's everything. Because it gets into the system in one way or the other. I know Villanova I think a lot of it is education on the use of salt, because everybody puts down a lot more than even what the manufacturer recommends. I know at Villanova we're very scared of lawsuits, and I've seen piles of salt after storm events. And we see it in the system April and May. We think there's like clumps somewhere in the system and the rainstorm keeps moving them down. So it is definitely an issue. But I don't have a great answer other than education of usage at this point.
My question is about sort of the political process to bring this all, together in terms of partnerships. How did that happen in Philadelphia? I mean, was there some kind of pressure?
Well, EPA basically said you had to solve this problem, or you would have a very large fine every year. So there was not a choice about solving it. It was how to solve it. And there was basically a group of very spirited individuals with vision who were able to convince the city that this was a way of bettering the life within the city of Philadelphia. And without those individuals, how it would have gone, I don't know. But now it's what do you call it? An example for many cities across the nation are using Philadelphia and internationally as well. And they invited me to China, to Beijing and Wuhan and a few other places to talk about what's happening in Philadelphia. So, and going over there, they need a lot of help in their water issues. But it's, I think basically you have to have the leadership who can have the vision of explaining what it could be. And luckily that's held, and people are very proud of it. So they still have to work on the maintenance. That's still the issue right now. Maintenance is too expensive. They got to bring that down. And we're working on ideas. We're actually looking at using drones for checking whether maintenance is needed or not. Now, I'm not sure when they're going to allow me to fly drones downtown Philadelphia yet, but we're working with our mechanical engineering department and looking at using infrared on some of the drone systems to take a look at the soils to see if they're clogged or not. So luckily we have a very good mechanical engineering program, some people I'm working with now, so I like their toys.
So let's assume that you continue to make more and more progress in Philadelphia. What do you do to get the rest of the country, if not the world, to follow your lead?
Well, a lot of the country is. And international, I have talked to people in Paris and Quebec City, all across, there are a lot of areas. The issues are always a little different everywhere. Seattle gets a lot of little rains, but they have a long period of the summer where they have no rain, and so green roofs are easier in Philadelphia than they are in Seattle. And because of that, there's more green roofs in Philadelphia. Run for office? I mean, basically, luckily water resonates with people. Everybody understands the need of water. And so they've done several surveys in Pennsylvania about what they felt passionate about, and water became. So Pennsylvania very early on was looking at water volume as a criteria within these new systems. And Philadelphia, I think it was the same thing. So first you have to have the problem to solve. And then basically people are very resident. I mean, they respond to water quality issues. And this is why we're working with people from the social sciences on this, which is well past my expertise. They were talking about having your cell phone went by a rain garden and ask you a question, whether it's been maintained or not, so they know whether to send somebody out. I'm not going to pretend I know how to do that programming, but there's a lot of issues. They have a very interesting conference on this every year. I call it Low Impact Development. And basically, people all over the country are working on this. So the rest of the world, all I can do is show how good all the results are, and that's what we do at Villanova. Yes, sir.
You mentioned that part of the motivation to go in this direction was alternative was the job creation.
Yes.
What are the jobs?
Maintenance. There's somebody, I mean, Philadelphia is a very poor city. There's a lot of, in fact, they've developed a program for like first-time offenders with minor convictions for drug use or something, and training them and getting them into the workforce. Obama even came to Philadelphia. And these kids they're now hired to maintain these sites. So they figured out they don't need a landscape architect every time to go out and look at a rain garden. But you need somebody to pick up the trash, and some of those issues as well. Those are some of the issues: horticultural, construction, those type of things.
So presumably the capital cost is less, but the maintenance cost is higher.
Yes, over time. I mean, our rain garden in Villanova, our maintenance practice really has been every year cutting down the grasses and raking them out once a year. And I would say that's cheaper than running the mower over the same area multiple times a month over the year. Now, the problem in Philadelphia has a lot more trash than Villanova has. And so actually this is where everything fits together. It's kind of neat. They just announced they're trying to be a zero litter city in 20 years. So they're talking about no more of the plastic bags or a cost for the plastic bags. Philadelphia does not have street sweepers because the cars are in the way. But they're looking at going back to street sweeping. And so this would actually cut down the costs of maintaining the rain gardens and extend the longevity of these systems. So it's one thing that's interesting about working in this field. There's so many areas. We're working with somebody who was at Penn, he's now at MIT in economics and computer science, and
Are these anecdotal estimates or are they hard analysis?
I'm sorry?
Are these anecdotal estimates? Or
Which?
The trade-off?
Oh no, they spent 5 or 6 years developing this study to see which way to go. Now, I don't know enough to look at the economics of the report, see whether it's right or not, but there was a lot of people with a lot of scrutiny on that from all sides of the issues. Because this EPA really didn't want us to do this. It was kind of interesting. They're at one half of EPA, which is the green people, were really happy. All the regulators hated it because they didn't understand how they could regulate that type of a system. So it's kind of amusing. Yes, sir?
Did you get involved in the design of the Hyannis Airport
No.
project, which is kind of similar to what you're talking about in Philadelphia?
No, I did not. I might know some of our alumnuses who live up there might. But it's
kind of interesting just to, if you haven't gone to the Hyannis Airport, just to walk through, and they've got an explanation of what the water does coming off the parking lot. So
Oh, cool.
how it's filtered, it goes into a pond and so forth.
Answering your question, going back, education is a very big part of it. That's why we really enjoy working with the STEM, which is with the kids on education, and also putting signboards. I put a few in a very visible area, put some explanation signs, because people do care about clean water, and it's kind of important stuff. Especially with, and the other thing that's kind of interesting on these natural systems, because it doesn't rain every day, if we have a couple more rains, I think we're starting to figure out they're a little more resilient versus some of the climate changes. But one of the things we have to look at is the plants might all change if the temperature changes. And so there's a lot of things to look at in those areas as well.
Have you done anything in Villanova with all your drain pipes coming off the roofs? Or do they just go into the...
They go into a pipe, we have disconnected some. We have done some of it. We've built 6 rain gardens in the campus that I mentioned earlier. We've built some infiltration trenches. There's a lot more we could do.
Yeah. There was a building in our town that I thought was very innovative, where instead of drain pipes, it looks like anchor chains.
Oh yeah,
Coming down,
rain chains.
And the water,
We had a conversation of that.
the water sort of
Yeah, they're cool.
sprays the plants,
Oh.
and you don't need a drain.
One more question.
I think I'm being cut off. I'll be glad to stay here afterwards. I love questions. This is great. So now that you said that,
One more question? Well, I'll ask a question.
Sure.
This pervious and impervious surfaces you were talking about, where is it that they're going to charge you for your impervious surfaces?
Philadelphia.
Philadelphia, have they started doing
Oh
it?
yeah, about 2 years ago.
And what sort of an impact has it had?
Oh, a lot of people are very mad. They can't charge the true cost of the impervious because it was too much of a shock. Impact, I think it's more visibility at this point. It's still not enough money to
Cause a change of behavior.
cause a change of behavior, but it helps because some people have And that coupled with the city going out to a business and saying, you got a big parking lot, let's make some changes together, we'll fund 50% of it, and if you'll maintain it, that has made a big impact. And also, all new development have to design to remove the first 1.5 inches. That is hard. So that's, and we have a lot of empty buildings that are being rebuilt in some parts of the city. That has made a big change.
Okay, very good. Thank you very much.
Well, thank you.
Yes.
Thank you. Appreciate the question.